Okay, let's continue number 22. So we had three cases because we had three lambdas. And we substituted, remember lambda 1 was 1. And we used our row reduce echelon form operation or function on the calculator. And we obtained the following matrix, right? Just copied and pasted this part. And we have this nice system, and this is very, very nice because we don't have to worry about the third a third equation, because I mean this is very nice because C is already 0, and then we have a nice relationship between A and B. So if A plus B has to give you 0, if A plus B equals 0, then of course, if you solve for A, for example, then you get A equals negative B. Okay, so that's one relationship. So we're trying to find, so let's see, eigenvector, so 1 is going to be, right, remember this is A, B, and C, and so, well, we know C is 0, so that's 0. And here, you can pick any value. So, A is equal to negative B. So if B was 1, okay, if B is 1, then obviously A is negative 1, right? It's just the opposite. So that would be negative 1. So this would be your eigenvector. If you want to save space on your paper, you can write this as negative 1, 1, 0 transpose, right? That's the exact same thing. Now, if you, let's see, I think the book, I want to say the book has, has this answer. But if you don't see this answer, it's not wrong. Because again, there are infinitely many solutions. This really represents a plane in 3D. And there are infinitely many points on a plane. Your piece of paper, how many dots can you draw on there? There's infinitely many. Now, if you wanted to, for example, just because everybody thinks differently, that's fine. If you wanted to solve for B, well, if you solve for B, then obviously you would get negative A. Okay, so another eigenvector that would be exactly the same would be, let's see, well, C is still 0, and B is equal to negative A. So if A is, 1, then B would be negative 1. Now, I hope that you guys see that these are exactly the same. The only difference is there's a scalar difference of a negative 1 factor. So if I multiply this by negative 1, right, I get this new vector. Well, it's not a new vector, it's really the same vector. So again, it's really up to you, 1, negative 1, 0, which value you wanted to choose. Again, if you wanted to do, here's 0. Let's see, I'm using the B equals negative A1. If A was, 102, then B would be negative 102. Okay, so there's, again, infinitely many solutions for this vector. Again, because there's a ton of relationships here. B can be any value you'd like, but 1 is very nice. So we're going to do the same thing, the exact same thing with eigenvalue negative, well, let's write it down. Lambda 2, my lambda 2 was negative 2, and when you punch this in your calculator, so let me actually... Okay, so let me write this. Okay, so I'm substituting this negative 2, right? Again, this is a different, obviously, lambda into my original, right, A minus lambda I matrix. So we have, when we substitute the values, again, the diagonals are the only ones that are going to change. And we get 5, 2, 2, negative 5, negative 2, negative 2, and then 5, 5, 5, right? And again, this is a 3 by 4 matrix. And we're going to do the same thing, right? You're going to do RREF of, again, your 3 by 4 matrix. And then, of course, it's going to, spit something out in the calculator, your output. One more thing I wanted to say. Okay, so this matrix, again, there's so many different ways of doing this. This is the beauty of math. But I mean, you can work with this matrix and you have your calculator, which is completely fine. But remember just row operations if you want to make your numbers a little bit easier. I mean, these are not that hard. But, you know, I can divide this row by 5, and I would get 1, 1, 1, and then 0. So you can do that. If you wanted to divide both sides or multiply by half, you would get 5 halves, 1, 1. So if you wanted to work with more ones, that's fine. If not, I mean, you have your calculator, so that's okay. So after we punch that in, we get. So let me move this up a bit. Okay. So we have. Okay, let's write this nicely. RREF, right? And your whatever you call your matrix. And I think the last one I called A. So in my calculator it's B. And then I get the following matrix. So I get 1, 0, 0, 0, 1, 0, 0, 1, 0, and 0, 0, 0. And again, notice this is not the identity matrix because, I mean, if there was a 1 there, then yes, my solutions would be 0, 0, 0. But that wouldn't make sense in this case because our zeros don't help. But again, this is not, emphasize, right? This is not, that's not the identity matrix because, again, the identity matrix would be 1, 1, 1, and then, of course, zeros above and below. Okay, so let's find some relationships. So we have, again, A, B, C. So A is equal to 0. Very nice. B plus C equals 0. Very nice. And again, we basically have the same matrix, right? If we look above from our previous guy, the only difference is, I mean, our relationships. Instead of A plus B equals 0, we have B plus Z equals 0. And again, if I, just solve for B, for example, we know B is just the opposite of C. So thus, our associated eigenvector with our lambda 2 is equal to, well, A is 0, so that's going to be 0 no matter what. I don't know, if C is 1, then B is -1. And again, if you want to write the transpose to go green, that's fine. And lambda 3 is, again, analogous. It's the same process. But I still want to do it because one of our entries is it is not 0. And I want you to see what the matrix looks like. So I'm actually going to continue in the next video just so I can upload this and you guys can go ahead and view it. And it should be the last one, the next video, since this is the last problem in the section that I'll be doing. If you have any questions, please let me know. Again, I'm here in California, safe and sound, but I'm here, I'm busy, but the first things first, I am your teacher, and I knew I was going to move here a couple of months ago when I got the offer. So please don't feel like you're bothering me. You're not. I want you to ask me questions. My goal is that you succeed in this course, and I want you to do well. So please ask me questions. Again, you are not bothering me. I'm here to help. Okay, I'll see you in the next video.